Hi, I'm Dr. Rick Swartzberg, Vice President of Product Development for Relief Mart Incorporated. And today we're here to talk about our airflow patent that we actually utilize for our memory foam mattresses and other types of foam mattresses. One of the large concerns that the consumers have in the marketplace is how do you reduce heat flow in the mattress? I mean, how do you reduce heat buildup in the mattress? And we're talking about flow for a second there. One of the chief ways of doing that is actually by creating more airflow. Airflow is really important because it allows circulation and therefore the heat doesn't pool around your body. Now with foam, you're going to have certain types of foam. Some are going to be more closed cell, some are going to be more open cell. Open cell means that it has a little more breathability. Memory foam has gone from more of a closed cell to an open cell. So as an example, I'm going to give you 3 different examples of memory foam configurations. There is going to be a little bit more breathability through than there used to be, but it's still not nearly enough breathability to give you the airflow that you need. And we're going to show you that. So I'll talk about the 3 different configurations here for a minute. And I also want to mention that really there is no such thing as a mattress that doesn't have foam on the surface, because even a spring mattress, nobody wants to sleep straight on the springs. So it's really important to find out how we can make all these systems more breathable. So here's the first system that I want to show you. This is a good traditional example of how memory foam can be connected to channels underneath for airflow. But the problem is that there's no holes through the surface of this memory foam. So there's only so much breathability you're going to get, because like we mentioned, like I just mentioned earlier, there's going to be some blockage no matter what, no matter how much breathability you have from the open cell, it's only going to allow so much airflow. Another configuration that we can do is to put holes. And if you put holes through the memory foam, you're going to get the ability for a little bit more breathability through those holes, but there's no full circulation, because where's that going to go? You could put holes all the way through, but if you put holes all the way through, then there's a foundation underneath that your mattress needs to be supported on. So once again, airflow is going to be blocked. So the idea that we had, and we spent several years to develop this, was could we communicate the holes on the surface of the memory foam to actual connecting channels underneath? And that's what we did in this example here. So what we did is we created these holes, and then the holes actually bore all the way through, come underneath, and then actually connect to the channel. So what you're going to get is a full airflow type of circulation. Now, to prove that, what we did is we went ahead and purchased what's called a hot wire anemometer. And what we're going to do is this is going to set up for a second. It's going to go ahead and calibrate. This is a new system. It's been calibrated already, but during the first 10 seconds, it's going to go ahead and calibrate itself again. And the way it works is it has a hot wire inside this cap right here that's going to measure the amount of air flow through whatever, when we inject the airflow. And we're going to use a compressor here, so you'll be able to see quite a bit of air that comes through. And it's going to measure just how much is able to reach the hot wire, and when it reaches the hot wire, it actually cools it off, so it actually is able to see the difference in wind speed. So we're actually looking at velocity, which means that if it's getting a high number of meters per second, it means that there's no resistance, so it's actually the wind is able to travel through. So that will really give us an idea of how much air can actually flow through these things. So we'll start here with the first configuration that I think would be obviously, well, and we've seen from our study so far, would be the most effective, which is our patented airflow system, which combines the holes on the surface and again with the channels underneath. And we're going to go ahead and see just how much air is at, what the speed of the air is that's able to travel from using our compressor. So what I'll do is I'll put this at the bottom of the channel, and we'll hold it right there, and I will go ahead and put in one of the middle holes just a little bit, and we'll go straight down and see where that where the numbers pan out. What we're going to look for is the numbers to steady off, because when you first put it in there, right now it's holding steady at 9. So can you hit hold on that for me? So Brad's going to help me out here, and he's going to hit hold, and he's going to go ahead and show the camera right now. It doesn't matter if I push it or not. It's at 9 meters per second. So what I want to do next, and by the way, let's go ahead and see if we can reproduce those numbers again. Oh, yeah, hit hold again because it's got to go back to 0. Okay, good. And so we'll go ahead and hold it again, and we'll see if it comes pretty close to that. I mean, it doesn't have to be exact, but I want to know, because all I have to do is move my hand a little bit, and it'll be a little different. But let's see approximately where it comes out to be. And go ahead and hit hold when you're done there. And what's the number on that?
10.6.
Okay, so 10.6. So we got about a difference of 1, but we have an overall idea of where we'll go. Let's try it one more time because it's always good to do 3 of them. And we'll just take approximate average and hit the hold button and we'll bring it back down to 0 again. Okay, good. And make sure that I haven't moved that. And when you're ready, go ahead and hold. And we have I believe that was 8.9. So now we have 8.9. We have, I think it was 10 and somewhere around 9.0. So we're averaging close to around 9 or so. So now what we're going to go ahead and do is show you how the air works and how much airflow we're getting in a system that has holes but does not have any channels. And then we can see what the difference is. So let's go ahead and put this in one of the same type of middle holes. And by the way, they were punched with the same type of a hole maker, and so these are actually done on the same exact lot, so there's no difference in the hole size. And we'll go ahead and bring that down here. And I'll put down just where that channel would normally be, right at the bottom there. And let's see if we can get any airflow through there. Okay, nothing's coming so far. I'll go down a little bit more and see if there's anything at all. Why don't you get a hold so they can see it? And hold it up. Actually, we don't have to hit hold. It's just 0. Hold it all the way up to the camera. The camera can see it. So nothing's happening. We have holes, no channels. Let's move it around a little bit. Does it make a difference if I move it there?
Still 0.
Okay. So still 0. We're not getting any airflow through here. Okay, we're going to stop that. So let's go ahead and now go to the idea of no holes but putting channels underneath, and let's see if that's got any breathability there. So we'll go ahead and put this down at the bottom of the channel just like last time. Put it right about at the middle. And let's see what that does. Okay. And hit hold, please. So it's focused in at 0.4, it looks like, right? Okay, so that's got a little bit more breathability. And again, that's thanks to the fact that you have an open cell memory foam. You're going to get some breathability through the memory foam, but as you can see, that's going to be somewhere approximately about a 20 times difference or more, depending on the situation. So now we're going to look at is, now that we know that there's more breathability through the channels, these two actually had more, but of course there's much more when you have the combination. The other point is, what about from one hole to another? The idea here is that with this one, we have the holes that communicate with the channels underneath. So if I put the air in here, there might be some air that comes up through here. So let's see if there's any difference. We'll go ahead and try that right now. I'll put it in, let's try this hole right here, and we'll try the second to last hole over there, and let's see what that does. And when it steadies out, we hit hold, please. And what did that come out to be? So that's 2.5, okay? So 2.5 meters per second. Let's go ahead and see what that does with the two holes here. So we're going to do the second hole to start with, and the second to last hole right here. Okay, and here we go. And when it steadies out, go ahead and release it. Go ahead and hit hold. And show the camera. So we're looking at a 0.1. So big difference there. Once again, actually, it's about 20 times different than... so now you have a situation where you are getting something here. You're getting about 20 times more here than you are here, and here you're getting about 20 times more than you were with just the channel. So it's very interesting. Let's go ahead and try it now through here and see if we get anything through the top by choosing the same channel. So we're going to put it right over where the channel is. And we'll go ahead and hit that. And let's see if we get anything coming up through there. And 0, but hit hold so they can see it. Hit hold, please. As you can see, nothing's coming back up through there that we can register. The anemometer is actually very sensitive, which is nice because the hot wire makes it more sensitive than other type of equipment. So we're able to get at least 0.1 and up. So this is when it shows 0. That's 0 basically. Anything less than that would be, so anything less than 0.1 meters per second is going to show 0. So now you have a difference with all three, and while you have a little bit more airflow coming up through here, you didn't have any airflow coming up through here. So that means that you're not getting any transfer of air coming back up to the surface that way. So let's try one other direction. And the other direction we're going to do now is we're going to put it through the channels and see, and through the side here, and we're going to see if anything comes up through the top that way. So let's go ahead and do that, and we're going to, we'll start with this one right here. We're going to start with our patented system, and we'll come up right in the channel, and we'll see if anything comes up, you know, to the middle hole. So here we go. And hold whenever you're ready, whenever you think it's consistent. Okay, and that's 1.8. Now an interesting thing is I'm actually letting the air flow through there. If I block it, show how much different it is here. If I block it just with my body, you'll notice it's probably quite different. Well, it was 3.1 and then it went down to 6 when you're right where. Let's try it again. Okay, I'm blocking with the body again. Okay, so it wasn't as different as I thought at that time, but I know sometimes if we put a good suction there, I kind of just put my body a little bit, but if you put a big suction, of course, it'll increase. So I'm trying to keep an open area and show you that. So we'll do that again for right here, and we'll put it right in the middle. And let's see here. Right about where the channel would be created, we'll go ahead and hit that same thing. And what do you got? 0.1, go ahead and hit hold and show the camera. So as you can see, again, about a 20 times airflow difference. And then we'll go ahead and try it through here. And it's 0. It's not changing on this one at all. So there's obviously some advantages to having holes. You can see the advantage of the fact that even without our full communication system where the holes can actually interact with the channels, you're still going to get some advantage where if you put into one hole, you'll probably get just a very small amount coming out through the other hole. If you don't have any holes, then that means that the airflow is probably not going to come up, through the other holes at all. And if you have channels, then you're actually going to create more airflow when you put that air through here than if you just have the holes without any channels. So it's interesting that when you look at it that way, that the system here has the best of both worlds. So if this is 20 times less than that department, and this is 20 times less than that department, when you combine the two, it's actually much higher percentage of airflow that you're getting all the way through. So this hopefully illustrates the difference that we're not just telling you we have a system that could hypothetically work, but we actually have a system that's reproducible and actually showing the difference when air flows through it. What we're going to show you next is kind of fun. We're going to show you actually what it looks like when the actual liquid smoke is put through the hole, so you can actually see it come up for yourself. This way you'll have more of an actual idea visually of how that all looks. See, it's coming up through here. I don't know if you could see this rising up here, all throughout the holes. It's coming out here, but can you see here? And if I plug it here, you'll see even more. But either way, I don't know if you could see it against the backdrop of my shirt, but the smoke is coming out through all these holes. I can actually feel it coming out through there.